Here we are going to discuss the critical value or classical approach for chi-square test. So first, you've got to identify the appropriate chi-square test. And then second, you have to state a pair of hypotheses. So after the appropriate chi-square test has been identified and the pair of hypotheses have been stated, and this will be guided by the actual example. For the null hypothesis and the alternative hypothesis for chi-square test, both statements are written in verbal form. So here you have the statements for chi-square test for goodness of fit, or chi-square test for variation. Here is the pair of hypotheses. So the null will be saying the observed values are equal to the expected, and the alternative will be saying the observed values are not equal to the expected. So this is the pair of hypotheses for chi-square test of variation or goodness of fit. Then you have a chi-square test for randomness. This test deals with the verification of the randomness or not of one distribution or a set of values which are observed values. So you'll only be given one set of values, which will be the observed values. For the chi-square test for variation, you'll be given two sets of values. So the historical will be the expected value, and the current will be the observed values. But for the chi-square test for randomness, you'll be given one set of values, which will be the observed values. And the null will be saying that the distribution is random, and the alternative will be saying that the distribution is not random. The expected values will be calculated by finding the average of the observed values. So the null, I repeat, will be saying the distribution is random, meaning there is no factor affecting the distribution. Basically, the null will be saying there is no factor affecting the distribution, and the alternative will be saying that the distribution is not random, that there is a factor affecting the distribution. And the chi-square test for independence, or chi-square test for no association, this deals with the verification of the association or not between two variables, TW, of a subject of study. So the null will be saying that there is no association between variable A and variable B, and the alternative will be saying that there is an association between variable A and variable B. Then the third step is to sketch a distribution curve. So for the chi-square test, the distribution curve will always be a right, skewed to the right. Okay? So for the chi-square, the distribution curve will be skewed towards the right. Unlike the z-test, which will be a normal curve, for the chi-square, the curve will be skewed to the right. And step number 4 is to locate and shade a critical region. The critical region will always be on the right. So as you can see, for the chi-square test, no matter if it's goodness of fit, or randomness, or no association, the critical value and the critical region will be on the right side, as you can see. Step number 5, the critical value, as I see, will be a positive number. It will come on the right side of the curve. Here it is. Step number 6 is to calculate a test statistic. This is the formula. This formula is comparing the observed and the expected. So it's O minus E all squared divided by E. You've got to do that several times. It was 4 or 5 times, and then you've got to sum this up, and the summation will give you the chi-square test statistic. Now, the chi-square test statistic now has to be plotted on the distribution curve. Remember, the distribution curve have the critical value already on the critical point. So you must look at the value of the critical value in order to plot the test statistic on the correct position on the number line of the curve. And then decision time, we are familiar with this decision time. You reject the null if the test statistic is in the critical region, and you do not reject the null if the test statistic is not in the critical region. And conclusion, if the null is rejected, okay, so if the test statistic is in the critical region and you reject the null, then the alternative will be the conclusion. And if the test statistic is not in the critical region and you do not reject the null, then the null itself will be the conclusion. And here, in example 9.4, there's an example of a chi-square test for variation. As you can see, the steps are followed very closely here. And example 9.5, you have a chi-square test for randomness. Here you go the steps. And example number 9.6, chi-square test for independence or chi-square test for no association. So you've got to go through these examples in order to make sure that you can perform a chi-square test for either randomness, variation, goodness of fit, independence using the critical value.